All right. Hey, everybody. Welcome back. This is session 2 for understanding how to read the inferred properties of Earth's interior. And I'll pick up where we left off. So last class, we learned how to read the top portion right here of the chart. But then if you look down or scroll your page to the bottom, there's 2 of the graphs that go with it. And what this chart does is uses these dashed lines to show that these layers are extended. So for example, everything between this blue here, that blue line, and that blue line, so everything between these 2 blue lines is in the outer core. And then they kind of extend those lines down, these dashed lines, saying follow these lines to read the 2 graphs below. Okay, that's what that is visually trying to show you. Okay, this is not. So let's follow those 2 lines all the way down. Let me draw them. So if I continue following these lines down, hopefully you could draw a straighter line than I can here. You'll eventually get to your x-axis. Okay? Oh my gosh. Bear with me. I'm learning this. I will eventually get better. So there we go. Okay? So between those blue lines is your outer core. See right here between those blue lines, and then I just extended it down. And that's what you would do for each of those. So the x-axis is giving you the depth, how deep below the surface. So 0 is sea level, and as you go to the right here, you're digging deeper, deeper, and deeper into the earth until you get to the center. So this point right here is the center. See, and they actually tell you that. So here, see that point is the center right here where my cursor is. That's the center. So if you follow it down, that should be the deepest part of the earth. So it's greater than 6,000 kilometers. So if I ever asked you, how deep is the center of the earth? I would probably accept any answer between 6,000 and 6,500. So maybe 6,200 or 6,300. I would most likely give it as a multiple choice question, and the answer would be pretty obvious. All right? Okay. So if I asked another question, like, where does the outer core begin? Why is this so difficult? Where does the outer core begin? That's this blue line here. So I would follow that first blue line all the way down to here. And just be careful. I'm going to erase this now because you're not going to have this in color. So it's this dashed line right here. See, it's this dashed line right here. So if I follow that down, is that dashed line to the left or right of the solid line that represents 3,000? It's just to the left of it. So that means the outer core begins at a depth just under 3,000. So just be careful. If you said 3,000, you would be wrong, because then you looked at this solid line, not the dashed line. So the outer core starts around 2,900 kilometers down. And then where does it end? Again, let me erase this part of the blue line. Okay. Well, where does it end? Well, if you look, if you look here, now that dashed line is to the right of the 5,000. So maybe it ends at around 5,100 kilometers. So if I said, what's the range of the outer core in depth? You would say the depth goes from 28 or 2,900 kilometers to 5,100 kilometers, and then take that difference. So it would be about, I don't know, 2,100, 2,200 kilometers in terms of total thickness from this point to that point. All right. Okay, so what else is on this graph? If you notice right here, in the y-axis, it says temperature, and it's in degrees Celsius. So as you go deeper into the earth, deeper and deeper into the earth, see this black bold line I'm following? That means it gets hotter and hotter and hotter. Okay? So if I asked you, what is the temperature at the boundary between the inner core and outer core? The way you would find that is you go, okay, temperature between the boundary of the inner core and outer core, well, that's right here. That's the boundary between the outer core and inner core. And I follow it down until I hit this black bold curve that says interior temperature. So that's where they hit at the boundary, and it's just over 6,000. So 6,200, 6,300 degrees Celsius. All right. If I asked, what's the temperature of the center of the Earth? So remember, look, this is the center. So it's basically the edge of this graph. So I would go down until I hit that bold line right here. Let me use a pen again. So I would follow, let me choose a different color. Red, since it's so hot. I would follow this down till I hit that curve, that temperature curve. And then I would look all the way over. Of course, please draw a straighter line. And it looks like it's just over 6,500. So like 6,600 degrees would be the temperature of the Earth's center. Okay? All right. Now, if you also are noticing, which you probably should have, there's this weird dashed line that like kind of follows the bold line and then leaves it and then comes back. That's very strange. This is the melting point. So this is the temperature, or the temperature that the material inside Earth would have to reach in order to become a liquid, hence melt. Okay? So if the temperature is hotter than the melting point, which is what we have going on right here, see how the temperature curve is above the melting point curve? That means it's hotter than the temperature that it can melt at, which means you're going to get a liquid. So last video class I gave you, I said this chart can kind of tell you that the outer core is a liquid. And this is where it's telling you that. So right here, the interior, because remember, between these two lines, look, is your outer core. So if I follow it down to here, that means inside the outer core, the actual temperature is hotter than the melting point, which means you have a liquid. So when you get this chart on the test, or you're asked to use it on a test, I would go right here and I would write down liquid. And then I would go right here to the inner core. See, this is the inner core. Look, see, I follow it down. And now the temperature curve is under. See, the black line, the black bold line is under the dotted or dashed line. So now that's too cold to melt. So I would go right here and write down liquid, and go right here and write down solid. But if you understand how to interpret the graph, they're actually giving you that answer. So once again, you don't truly have to memorize if you know how to read a graph properly. So this is showing that it's the outer core is melting, hence liquid. Here that it's a solid, so the inner core is solid iron and nickel. All right. Now let's go over that other weird layer, the one called the asthenosphere. Okay, it's probably the hardest one to pronounce. Remember, this is the one that can flow or has a convection currents. And how would you always remember that? You have the arrows here showing you that this is the layer that's flowing. This is also the layer that has the magma. That's why it's able to flow. And this gives you that answer. So if I follow this down, keep on following it down, see, follow it down to here. See how the black line and the dotted line are on top of each other? That means the temperature has equaled the melting point, which means you're kind of going to be half liquid, half solid, which is kind of what magma is. That's why it's called molten rock and not melted rock. It's not truly a liquid. And they're telling you that, see, partial melting. And there's a line pointing to right here. So what I would do is underneath this is write down magma. So then you actually could tell the magma is coming from the asthenosphere. All right. So here I would write magma. Here in this portion, I would write down liquid. And here, solid. And it's definitely a solid in this area called the stiffer mantle. But by calling it stiffer mantle, they're kind of telling you that. So if you wanted to write solid here as well, that's great. Okay. All right, so there's one more chart in here to interpret, and that's the pressure chart. So inside the earth, as you dig inside the earth, as you go deeper and deeper, is there more or less rocks above you? Well, obviously there's more. As you dig within the earth, the deeper you get, there's going to be more rocks above you. Well, that means there's going to be more weight. Well, if there's more weight, that means there's more matter pressing down on you, hence pressure. So the deeper you get into the earth, the deeper you get into the earth, hold on. See, the deeper you get into the earth, see, this is depth. Remember, it's the same scale on the x-axis. The pressure increases directly. It just goes up. All right? And your inner core is the most pressure. This is your crust, that bold line. So you just follow it down, is the least pressure. So as you go from the crust to the core, the pressure increases. And then if you look here, as you go from the crust to the core, the temperature increases. So what would you be asked about the pressure? Same type of questions with the temperature curve. You know, what's the pressure at the boundary between the outer core and inner core? So I go to this line, I go down, and it looks like it's about 3. But that 3 stands for million atmospheres, which means if you go down to the boundary between the outer core and inner core, that's like having the weight of 3 million of our atmospheres above our head. So we're accustomed to 1 atmosphere, right? We only have 1 atmosphere above our head, all right? About 20 feet of water is equal to the weight of another atmosphere. So if you ever dive down deep in a swimming pool, you start to really feel the pressure of the overlying weight of the water. You really feel it on your ears, all right? Now that's only 20 feet, so that would be like 2 atmospheres. Here we're talking about millions of atmospheres. So this would be the weight of 3 million atmospheres. So at the boundary between the mantle and outer core, I come down to here, it's like 1.5 million atmospheres. All right? So that's how I will test you on these charts. So follow along with these when you do the questions. So there's an attached Google document. Use this chart. I'm going to attach it again. along with this video and with questions that you can only answer by using these charts. So those questions will be like, what's the temperature at 5,000 kilometers? So I would go to 5,000 kilometers and I would go up and I would say, oh, the temperature is, I don't know, 6,200. It doesn't have to be perfect. When I ask you, what's the temperature at 2,000, a depth of 2,000 kilometers, you would go up and say, oh, it's about 4,200 degrees Celsius. Okay, and that's what you're going to be asked to do. All right, so hopefully you understand this. And once again, ask questions, email me if you need help. Have a great day. This thing's still taping?